Hi there, welcome to a quick video tutorial here on rational exponents. In this video, what we're going to do is investigate expressions with fractional exponents. So I want to just start off with a mini investigation. If you have a calculator handy, you type 4 and you raise that to the power of 1 over 2. Also punch in the square root of 4. You're going to notice something pretty special. In each case, what you're going to see is you get 2. 4 to the power of 1 half is 2, and root 4 is also 2. Now you could say, well, that's just a coincidence, but you can try this with any number that you can take the square root of. For instance, the square root of 9, you get 3. If you take 9 and raise it to the power of 1 half, you also get 3. So one other way you can prove this, if you treat these as functions, what I did is I just took x and I raised it to the power of 1 half. I've graphed that on this graphing calculator, and you can see that in purple here. And what I've also done is I've set up a function that's just the square root of x. And what I've done is I've shown that if I toggle the red and the purple, the red, this is the square root of x. I put the purple on and I take the red off, you can see that it's the same function. Okay, so this suggests that these two expressions are actually the same. And that's what we're going to conclude here, that if I take some number and I raise it to the power of a fraction, I can also express that as the root of x to the power of a, where b is the denominator of my fraction in my exponent and a is the numerator. So this is kind of a neat little trick. It kind of helps you with a lot of math problems that you're going to see in your studies. Very quickly, want to remind you of exponent law stuff that's kind of relevant for the rest of this video lesson. If I had something like this, 4 to the power of 1 half, and I raise this all to the power of 2, the rule that I'm applying here is the power of a power rule, which says I can just simply multiply the exponents together. Okay, so if I wanted to simplify this expression, what I would do is just take this 2 and I would multiply it by half, right? I'm using my exponent law, which says I can just take this guy, I can multiply by this guy. I've got 2 over 1 here. Remember, we don't write the 1. You just multiply straight across. So 1 times 2 is 2, 2 times 1 is 2. 2 over 2 is just 1, so what I have here is really just 4 to the power of 1, also known as 4. Okay, so you're thinking, well, how is this relevant to what we just saw? Okay, well, we have two conclusions here. The first one we had was that this relationship is true. We also know this relationship is true. So what I'm going to do is I'm going to combine these to evaluate some expressions that involve roots. And in order to do this, I'm going to apply both the conclusion we just came up with using the graphing calculator and our exponent law for powers of powers. What I have is the fourth root of 16 to the power of 3. Now, this is something that you could just punch into your calculator, but if you don't happen to have a calculator handy, this is a neat trick that'll help you evaluate this expression. Well, we don't really know what this is. We don't know what 16 to the power of 3 over 4 is. But if I kind of reverse engineer this exponent law, I can come up with an expression like this, which says that I know 3 times 1 over 4 is 3 over 4, and I can use my exponent law and kind of go backwards to come up with this expression. Now you're thinking, well, why would you ever want to do that? Right? Now this just looks worse. You've got brackets. Well, if you take 16, what I'm going to do is I'm going to take 16 and I'm going to write it as 2 to the power of 4, and you're thinking, how would you know that it's 2 to the power of 4? Well, what I do is I pick an exponent that's going to cancel out the fraction when I rewrite 16. So if I write 16 as 2 to the power of 4, I've got a power of a power so that these two cancel out nicely. And you can see that I've got 4 times 1 over 4. Okay, I'm just applying my exponent law. And I'd be left with just 2 to the power of 3. Well, 2 to the power of 3 is something we can do in our head. 2 to the power of 3 is just 2 times 2 times 2, also known as 8. Okay, so neat little trick. It does not require you to use a calculator. Okay, I'm going to try another example here. We've got the third root of negative 64 to the power of 2. So we're going to start by using our conclusion that we just came up with from the graphing calculator. And I'm going to say, okay, well, I can rewrite this by getting rid of the root. I've got 2 in my numerator, 3 in my denominator. Okay, and I'm going to use the same sort of trick that I just used. Okay, remember, I can take out this 2 and treat this as sort of a power type situation. I'm kind of taking this exponent law and working backwards. So I've got negative 64 to the power of 1 over 3, right? Remember, if I have a power of a power, I could call this 2 over 3. And what I want to do is take this number and I want to write it as some number to the power of 3 so that I can cancel out this fraction. Okay, so you kind of have to think, what number to the power of 3 would be 64? It's okay if you have your calculator handy and you just want to play with numbers until you come up with the right number. But in this case, if I take negative 4 and I raise it to the power of 3, I should end up with negative 64. It might take a little bit of trial and error to get used to it, But if you think 4 times 4 times 4, that'll give you 64. I can take this and I can replace negative 64 with this new expression, which will cancel out my fraction in my exponent nicely, leaving me with something that I am pretty comfortable with. I'm comfortable with negative 4 to the power of 2. That should just be 16, right? That's something we don't need a calculator for. All right, so just a couple of tricks for working with exponents where you can kind of apply some of these exponent law tricks to evaluate your expression without using a calculator.